Hey guys, welcome to the day one solving system by Graphing Notes. I want to start with the bell ringer, do a quick review here. We looked at this a little bit yesterday, but I want to make sure we're remembering how to rearrange something in the y equals mx plus b, name the slope, name the y-intercept. So you'll see I just added in an invisible 1 here on the x. We need to remember when moving this in the y equals mx plus b that we want the mx on the right side. So I'm going to move this over to the right using subtraction. These will cancel out, leaving me a negative 3y equals negative 1x plus 6. I do not want to put that together and make a 5. I am trying to put this in y equals mx plus b. From there I can divide everything by negative 3. This will give me y equals a positive 1 over 3x minus 2. Negative divided by a negative cancels each other out. So the slope here is going to be the letter m, which is 1/3. And then the b is going to be the y-intercept, which is negative 2. I want you guys to make a note that for today, when we look at slope, we're going to be thinking rise over run. And for the y-intercept, we're going to be thinking the starting point on the y-axis. So quick review. Just wanted to make sure we're remembering how to do that. Getting into the actual notes for today, I want to make sure that we're understanding what a system is. So what exactly are we going to be doing with these things called systems? And it's when we're going to be looking at two or more. In our notes, we'll be looking at two linear equations. So you can see right here I have equation 1, equation 2. And we will also be looking at two or more. In our notes, it'll be only two variables. So variables here, you'll notice that there is an x variable. We have one located in both equations, and there is a y variable for the second variable where we house one in each equation. So those two items is what makes up this thing called a system. So what are we going to actually do with these systems today? Well, we're going to start with graphing them, and our goal is to see where they overlap, because where they overlap gives us an answer. So looking at equation 1, they already put it in y equals mx plus b form for me. So we need to know that the m, which equals 3, is our rise over run. But my issue here is I don't have the run part. So just remember we can turn any number into a fraction by putting it over 1. And then the b here is my 1. It is going to be my starting point on the y-axis. So I'm going to go ahead and graph this, guys. We need to note that the y-axis is our up and down axis. Our x-axis goes left and right. And on this, I want to start with the 1. So I'm going to start on the y-axis at the 1. And then I'm going to do my rise over run. I'm going to go up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. And then I'm actually going to follow this pattern backwards and go down 3 to the right, or to the left 1. Down 3 to the left 1. Down 3 to the left 1. So our goal is to make a line of dots. And I'm not going to connect these dots, and we'll see why here in a minute. On this second equation, we have m equals 1/2, so we have our rise over run. Don't have to add anything to it. And then on our b, we have the 6, which is our start on the y-axis. So on this one, guys, I'll go up to 6. 1, 2, 3, 4, 5, and 6. And on this one, I'm going to go up 1 to the right 2. And when I do that, you're going to notice that I hit the red dot that was already there. When this happens, it's very important. We need to circle that. I am going to continue to make my line of dots just so you guys can see what these lines look like. So you can notice we have our blue line, we have our red line, and they have an intersection point. So this intersection point, you can see down here in this little circle here, I have the solution of a system is the intersection point. So this right here is my solution, and my solution is at 2 here on the x, and it's up here at 7 on the y. So it asks us to write this point down. So we need to write down 2 comma 7, and you need to understand that means x equals 2 and y equals 7. So this is everything we need to know about the answer. Depending on the notes that we're in, the worksheet that we are on, sometimes I will ask you to write the answer as an ordered pair 2 comma 7. Sometimes I'll ask you to write the answer as x equals and y equals. But really, I would like you to write it both every single time the way I did here in the box. So when we're looking at graphs, that'll be the way that we solve. Other things we'll see on our homework and could see on a quiz or a test is a problem where they give us some answers and they want to know, are these answers correct or not? So on this, it says, tell whether each ordered pair is a solution of the system. So this is a question, guys. Is this a solution? Meaning, is it correct answer? So somebody on this got an answer of 1, 7. We need to remember that that means they said x equals 1 and y equals 7. And another person said, well, I got the answer of x equals 2 and y equals 5. We have to determine who is correct. So we can do this without using a graph. We can plug these directly into our equations. So I'm going to start with A here, and I'm going to look at equation number 1. So I'm going to write this over here. And on equation number 1, we have y equals 4x minus 3. I am going to replace the y with a 7. And then I'm going to have my equals 4. I'm going to replace my x with the 1. And then I'm going to have my minus 3. When solving this, the 7 just stays a 7, so no big deal. 4 times 1 is just 4. Then I have minus 3. So I'm going to get 7 equals 1. Does this make sense? Do we think this is a good solution? And your thought process should be no. The way I like thinking about it is with money. If somebody had $1 and said, hey, can I trade you $1 for $7? You would look at it and be like, no, I'm not going to make that trade. I'd lose $6. This is not an equal amount. All right, thinking of money usually helps that. So with this, we can already tell this is not a good answer. Okay, this is not a good solution. It didn't work when we plugged it in. I do want to slide over to B here, though. Looking at B, I want to take the exact same approach and see what happens. So let's take equation 1. I'm going to have my y equals 4x minus 3 again. This time, the y is going to change to a 5. I'm going to have my equals 4. The x this time is going to change to a 2. I'm going to have my minus 3. And then I can start solving this. Well, 5 stays 5. 4 times 2 is 8. Minus 3, 5 equals 5. This is a good answer. I like this so far. If someone said, hey, I got a $5 bill, I need to get something out of the vending machine, can I trade you a 5 for 5 ones? You'd be like, sure, no big deal, same amount of money. We do have to check this for both equations, though. So we're finally going to actually use equation 2. And this one is the y minus 2x plus 9. I'm going to do the exact same approach, and I'm going to change the y into a 5. Oh, looks like I lost my equal sign here. I'll squeeze that in there. Equals negative 2. My x is going to turn into a 2. And then I'll have plus 9. So with this, a 5 stays a 5. This becomes negative 4 plus 9. And then I end up getting 5 equals 5. So once again, this is good. I would trade $5 for $5, 5 ones for a 5. So we can look at this and we can say that whoever had answer B would be correct. So this is our second way of checking answers slash solving answers or seeing if answers are correct, something we'll see on our homework tomorrow. So with this, guys, I want to just follow up with one more problem, make sure we're getting this before I conclude the notes for today. We will look at y equals negative 3x minus 5. So with this, we have m equals negative 3, which is our rise over run. And with this, guys, make sure that if you need to add in a 1 there, you do. I have my b here, which equals negative 5. So this is my starting point on the y-axis. So I have my y-axis, I have my x-axis. I need to start at negative 5. So 1, 2, 3, 4, and 5. And then I'll do my rise over run. Well, this time my rise is negative 3. Sounds a little weird. Rise, you think up. But negative 3, we need to go down 3 and then to the right 1. If we try and go down 3 and to the right 1 again, we're going to run off the graph. So I'm going to start doing this pattern backwards. I am going to go up 3 to the left 1, up 3 to the left 1, up 3 to the left 1, so on and so forth until I get my line all the way across the graph. I can now go to my other equation. I can see that m equals 3/2, so I have my rise over run. And my b equals 4, so I have my starting point on the y-axis. So I'm going to start up here at 4, 1, 2, 3, and 4. And on this, I'm going to have to go up 3 to the right 2. So up 1, 2, 3 to the right 2, up 3 to the right 2. I run off the graph, so I'm going to follow this backwards now. I'm going to go down 3 to the left 2, down 3 to the left 2, down 3 to the left 2. When I do that, I hit this dot that I've already drawn. That's a very important dot. We know from the first example that's our answer. I am going to continue this just to draw the line all the way across the graph. So guys, we can see our two lines intersect here where I have it circled in green, and that is at -2, and it looks like a +1. So our solution here is -2, 1. You guys need to know that means x equals -2 and y equals +1. Those are the two main topics we're going to be looking at on our worksheet, guys. If you have any questions, make sure you're asking in class. If you want to work with somebody else to try and get some help from them, you'll be able to do that as well.